Hello everyone. So in the previous part of the lecture we had derived the relationship between sigma x dash and sigma xx sigma yy and tau xy using the force balance along the x direction. So what we are going to do next is carry out a force balance in the y dash direction to obtain a relationship between tau x dash y dash and uh, sigma xx sigma yy and tau xy again. So let's do that. First of all, I'll have to draw the figure again. So very quickly I'll try to do that. So the vertical edge first, the horizontal, uh, this will be sigma xx tau xy sigma yy and tau xy. Uh, so I'll carry out my force balance now. Sigma f y dash is equal to 0. Now just as I had done earlier, I'm going to consider my edges L, M, Mn and Ln. Let me depict it here quickly. So this was L, M, N, and we remember that Ln had the area A, L, M had the area A cos theta, and Ln, sorry, Mn had the area A sin theta. So first of all, considering the face Lm and first of all considering the force associated with the stress component sigma xx, which is this. So we write that as sigma xx. Lm has the area A cos theta. We write that down quickly. Now this force is directed along x, and we need to take the component of it along the y dash direction. So you note here that the direction I'm interested in, so maybe I need to draw that parallel to y dash. So this angle, you note that this is my x direction, this is my y direction, and this is my angle theta. So this angle was theta, which means this angle is 90 degrees minus theta. So this is cos of 90 degree minus theta, that is sine theta. That is along the y dash direction. Now let us write down the contribution from the tau xy. So the tau xy that is lying on the edge Lm. So this is tau xy, again a cos theta. So we are considering this particular force, and we have to take the component of it along the y dash direction. So this force itself, the tau xy a cos theta, is along y direction. We have to take it along the y dash direction, parallel to the y dash direction. So we are actually considering this angle, so that's theta. So now for the first term as well as for this term, I have not written down the signs. So let's check what should be the signs. So for the first term, that is considering the sigma xx a cos theta sine theta again, this is along the y dash direction. So this actually comes with a positive sign. However, the second term, which I have just written down here, the tau xy a cos theta, that is along the negative y dash direction. So it should come with a minus sign here. Next, we considered the edge Mn, the face Mn, and we considered the force associated with the stress component sigma yy. So sigma yy multiplied by a sine theta, which comes from the area of the face Mn, and we have to take the component of this force along this direction, which is the y dash direction, and that angle is theta. So that is cos theta, but this is along the negative y direction, so the negative y dash direction rather, so this is with a minus sign. Next, we considered the force associated with this tau xy, which is on Mn. So we write that again, tau xy, area of Mn is a sine theta, and the contribution or the component of that force along the y dash direction, we have to consider this angle, which is actually 90 degrees minus theta. So that is cos of 90 degree minus theta, so that's sine theta, but that happens to be along the positive y dash direction, so it is a plus, just like the first term involving sigma xx. And finally, let us not forget the face Ln, for which we have to consider the contribution from the tau x dash y dash, that is this one, which is entirely along the y dash direction. So tau x dash y dash multiplied by a, which is the area of the face Ln, and since it is entirely along the y dash, we don't have to take any component, so that is equal to 0. So that is of course with a plus sign. So all in all, what we'll have after cancelling out the common coefficient A, tau x dash y dash is equal to minus sigma xx cos theta sin theta plus sigma yy sin theta cos theta plus tau xy cos square theta minus tau xy sin square theta. All right, so we can simplify it a little bit further. Tau x dash y dash is equal to minus sigma xx cos theta sin theta plus sigma yy sin theta cos theta plus tau xy taken as common cos square theta minus sin square theta. Okay, so if we look at the last bit of the previous part of our lecture, we had obtained an expression for sigma x dash, and now we have obtained an expression for tau x dash y dash. So let us collect these two expressions and write them together. So we'll just repeat this expression, sigma x dash and tau x dash y dash from here. So just rewriting it here. All right, so what we can do is we can use the trigonometric identities which you are familiar with from our high school maths and rewrite the sigma x dash as so we are obtaining it from here. So this will be 1 plus cos 2 theta by 2 plus sigma yy 1 minus cos 2 theta by 2, and this one is simply sin 2 theta. So if we rearrange it, what we'll obtain is sigma xx plus sigma yy by 2 plus sigma xx minus sigma yy by 2 cos 2 theta plus tau xy sine 2 theta. So this is our expression for sigma x dash x dash. We'll number this as our equation 1. Next, we would like to do a similar sort of rearrangement for our tau x dash y dash where we note that this can be easily simplified. The first two terms and this is simply half of cos 2 theta. So we'll call this as equation 2. Note that although we have obtained expressions for sigma x dash and x dash and tau x dash and y dash, we have not really worked out what should be the expression for sigma y dash y dash. But we really don't have to get into the details of it, because you note that because our y dash is just rotated from the x dash by 90 degrees, we can simply obtain the expression for sigma y dash by replacing theta by theta plus 90 degrees. That's all we have to do. So very quickly we can obtain that expression for sigma y dash, replace theta by theta plus 90 degree in the expression of sigma x dash. So all that you have to do is go to 1, so in this equation 1 we just so that is 180 degrees plus tau xy sine 2 theta plus 180 degrees. So overall what we'll have is sigma xx plus sigma yy by 2 minus sigma xx cos 2 theta and tau xy sine 2 theta. So this will number as equation 3. So these are our expressions for sigma x dash, sigma y dash, and tau x dash, y dash. All right.